Over 3 billion cubic kilometers of water flow in Earth's oceans, humming a timeless lullaby across 71% of our planet. These gentle waters, swaying with the moon's tides and pulsing through currents like the Gulf Stream, cradle the heartbeat of life itself. What ancient secrets do these waves whisper about life's beginnings? How do tiny phytoplankton, dancing in their depths, breathe oxygen into our world? Tonight, Cosmic Sleep Science invites you to sink into the most relaxing ocean facts, crafted to soothe your heart and spark quiet wonder as you drift to sleep. Subscribe, close your eyes, and let the ocean's tender embrace guide you into dreams. Billions of years ago, the young Earth was a world of fire and stone. The surface boiled with magma seas and violent eruptions tore through the crust. Yet from this chaos, water began to gather. Around 4 billion years ago, comets heavy with ice struck the planet. Their frozen cargo melted into steam, then rain, then rivers. Volcanic outgassing released vast clouds of vapor into the skies. Slowly the air cooled. Slowly the drops fell. The first oceans filled the scars of Earth. Tiny zircon crystals found in the rocks of Australia whisper this ancient story. Their chemical patterns reveal that liquid water shimmered on the planet far earlier than once believed. But the question lingers. Where did all this water truly come from? The volumes are immense, vast enough to wrap the world in blue. When we look toward Mars, we see a different fate. Signs of dried valleys and frozen caps remind us that Mars once held rivers, yet they vanished into dust and cold. Our oceans endured. Their presence seems almost miraculous. Imagine the silence after the storms of birth. Imagine the newborn planet wrapped in oceans like a cradle. Out of cosmic violence, a lullaby began. The seas rocked the Earth into rhythm. A rhythm we still hear when waves touch the shore. In their depths, the memory of fire still sleeps. Yet on the surface, only calm remains. The oceans are a gift from time and chance. They hold the story of beginnings in every drop. They are the oldest mirrors of the sky. When you close your eyes tonight, you can feel that ancient calm. The oceans breathe for you. They have breathed for billions of years, and they will keep singing long after you drift into rest. Scientists continue to debate the origin of this water. Some hold that it came mostly from comets that wandered inward from the cold outer belt. If that is true, then the oceans are a cosmic gift delivered across light years. Others argue that Earth carried its own water within the mantle. When the planet cooled, gases rose from the inside. They condensed into endless rain that lasted for millions of years. If that is true, then the oceans are Earth's own creation. Both ideas reveal wonder. In Namibia, pieces of meteorite have been found that still carry water within their stones. They are reminders that the universe itself is not dry. In the earliest ages, clouds rolled across Earth for eons. Rain hammered down on hot plains. Steam rose again and again, until finally the land drowned in blue. The mystery deepens when we ask why Earth kept its water while Mars and Venus lost theirs. Our atmosphere was strong enough to hold the vapor. Our magnetic shield protected us from the solar wind. Without those shields, the oceans would never have stayed. It is as if the planet itself decided to keep breath. The debate continues in laboratories and conferences. But for you tonight, the answer does not matter. Whether from comets or from fire, the oceans arrived. They settled into valleys and spread into basins. They became the foundation of life. They became the surface of dreams. Listen to the thought. Our oceans may be older than the first cells. They may have waited for life to begin. Every tide you hear is a continuation of that waiting. It is the sound of the planet remembering its birth. When you rest tonight, imagine the endless rain of the early Earth. Millions of years of falling drops. Millions of years of gathering seas. That rhythm is the same rhythm that now flows in your veins. The oceans are not only outside you, they are within you, and they invite you to breathe slowly. The oceans today cover 71% of Earth's surface. They are the blue skin of the planet. Within them rests 97% of all the water we know. Without them, Earth would be a dry sphere. a desert adrift in space. But with them, the planet breathes. The oceans regulate climate in ways both subtle and vast. Currents move like rivers across the globe. The Gulf Stream flows from the tropics to the north and warms Europe with its invisible touch. Without that warmth, much of the continent would lie frozen in endless winter. Other currents carry nutrients across thousands of miles. They feed unseen life in waters we will never see. In cores of ocean sediment, scientists discover microbes that have slept for millions of years. Some still stir when touched with light and air. They are the oldest witnesses we can find, patient keepers of the memory of the sea. The oceans are not silent. They are the pulse of the planet. Their tides move with the pull of the moon. Their waves break on shores like a heartbeat heard in the distance. They are constant and quiet, and they hold the balance of all that lives. Imagine Earth without this rhythm. Imagine the silence if the oceans stilled. Climate would collapse. Forests would vanish. Skies would turn harsh and thin. But with oceans breathing, the planet remains alive. For you, the ocean may be far away, yet its touch is everywhere. In the wind that carries salt. In the rain that falls on your window. In the clouds that drift above your dreams. The oceans connect every place to every other place. They have no walls. They have no borders. They flow in and out of your life with a grace you do not need to command. Tonight, when you rest, you can let their pulse steady your own. The oceans breathe and you breathe with them. They are the gentle lungs of Earth. Let the soothing tale of our ocean's cosmic birth and gentle rhythm wrap you in wonder. As cosmic sleep science guides you through Earth's heartbeat, subscribe to drift deeper into these tender, universal stories. There is another gift the oceans carry. They give us breath itself. Between 50 and 80% of the oxygen on Earth is produced in the sea. It comes not from the great forests or the jungles alone, but from tiny beings drifting in the waves. They are phytoplankton, small as dust, fragile as mist, yet powerful enough to keep the world alive. Each one captures light and turns it into air. Each one multiplies across the blue. In their billions, they outshine rainforests in the work of breathing. They have done this for ages. In rocks 3 billion years old, fossils of ancient microbes tell us that oxygen first rose from the seas. The oceans were the first lungs of Earth. They remain the lungs today. And still a mystery waits within this truth. How can creatures so small, unseen by human eyes, keep the entire planet supplied with breath? It is a question that humbles science. It is a question that humbles us. The oceans are both vast and delicate. They depend on balance. When the balance shifts, their rhythm falters. Yet for now, they continue, steady and generous. Each inhale you take tonight may be traced back to a wave breaking under the sun. Each exhale may drift into the air and someday fall again as rain into the sea. The cycle is endless. The cycle is tender. If you close your eyes, you can imagine yourself as part of it. You breathe and the ocean breathes with you. There is no separation. The plankton, the waves, the tides, and your own chest rising and falling are all one rhythm. This is the quiet gift of the sea. It does not ask you to notice. It does not ask you to praise. It simply gives, and in this giving the world endures. Tonight as you lie in stillness, you can feel that gift wrapping around you. The oceans hold you. They hold everyone. They breathe so you may rest, and they will keep breathing long after dreams have carried you far. The ocean is vast, and most of it remains unknown. More than 80% of the ocean floor is still unmapped. Scientists call this the last frontier on Earth. Sonar and satellite tools have traced some shapes, but they have revealed only a fraction. Beneath the surface lies a world of ridges, trenches, and hidden mountains. One of the greatest discoveries is the Mid-Atlantic Ridge. It stretches for 65,000 kilometers across the ocean floor. That is longer than the distance around the entire planet. Imagine a mountain range taller than the Himalayas, yet hidden underwater. These ridges twist and rise in silence. They separate tectonic plates and create new crust with slow eruptions. The scale is almost beyond the mind. Yet we see only small pieces through remote cameras. The rest is still in darkness. What lies there? Perhaps valleys deeper than any canyon on land. Perhaps species that glow with light we have never witnessed. Perhaps secrets that remind us of other worlds. Compared with Mars or Venus, the deep ocean is closer, but in many ways it feels just as unreachable. To descend is to step into night without stars. Machines struggle against pressure that could crush steel. Human eyes have seen only tiny corners. Each map we draw is filled with empty spaces. Spaces waiting for answers. The ocean hides its heart with patience. For now we only know its surface. We only hear its waves and see its tides. But beneath that calm is a library still locked. When you rest tonight, imagine those hidden ridges. Imagine an entire world below your feet. A world as grand as the sky above. It waits in silence. It waits with mystery. And it calls us to wonder what lies in the deep. The mystery of the ocean floor invites both science and imagination. Some wonder if traces of forgotten civilizations may sleep under the waves. Legends of cities swallowed by the sea still live in human stories. Others believe the deep holds only ecosystems beyond our knowledge. In either vision, the truth remains hidden. What we know is already enough to stir awe. In 1985, explorers found the wreck of the Titanic more than 3,000 meters below. The ship lay preserved in silence, a human memory kept by the sea. In the Pacific, scientists found coral reefs where no light should reach. Entire communities of fish and invertebrates thrived in the dark. Each discovery shows that the ocean floor is not empty. It is alive with stories of past and present. Some are human. Some are older than human memory. The seabed is like an unopened book. Each page is thick with weight, sealed by salt and time. To open it requires patience. To read it requires courage. And yet the book remains mostly unread. As you drift to sleep, you may imagine it waiting. Imagine chapters still unwritten. Imagine images of landscapes that few will ever see. The deep floor is not silent. It whispers in ways we cannot yet hear. Perhaps one day we will answer its questions. For now, it rests beneath us. It supports the continents and cradles the seas. It is a foundation we rarely consider. And still it waits to tell its story. In 1977, a new discovery changed our vision of life in the sea. On the ocean floor near the Galapagos Rift, scientists found hydrothermal vents. From these cracks in the crust poured water heated to 400 degrees Celsius. Black smoke billowed into the dark, carrying minerals from the deep earth. What they saw around the vents was even more astonishing. Entire ecosystems flourished without sunlight. Tube worms grew taller than humans. Clams clustered around the chimneys. Crabs scuttled across fields of black rock. The secret to this life was not photosynthesis, but chemosynthesis. Tiny bacteria fed on the chemicals released from the vent water. They turned poison into food. They became the base of a new food chain. It was life built from fire and stone, not light. The idea shook our picture of the world. Until then, we believed sunlight was the source of all energy. Yet here in the deepest night, life burned bright without it. Scientists compared these vents to potential alien worlds. If life can thrive without sun here, then perhaps it can thrive on icy moons or planets where light never reaches. Europa around Jupiter, Enceladus around Saturn, may hold oceans like these. The chimneys of Earth become windows into space. In the deep darkness, life blooms, like sparks in the void. It is a reminder that existence finds a way in the most unlikely places, and it is a lullaby of resilience whispered by the sea. The vents hold mysteries that still puzzle science. How does life endure such heat and pressure? At depths where human bodies would be crushed and where boiling water pours out like breath, creatures thrive. Their cells resist forces that would break almost anything. Their proteins remain stable at temperatures near fire. Some believe that these vents may tell the oldest story of all. They may be the birthplace of life itself. In the cracks and the heat, molecules may have combined for the first time. Energy and chemistry may have created the spark of beginnings. Others argue that vents are not origins but exceptions. They are simply oases in the desert of the sea. The debate continues. Yet each time we watch the vents, the thought returns. Are these chimneys telling us how life began? Or are they simply reminders of how diverse life can be? The answer is not yet clear. But the wonder is already here. In the silence of the abyss, towers of stone rise and breathe. They exhale warmth into the cold. They gather creatures into community. They glow with minerals that look like stars. As you drift into sleep, you may imagine them waiting. Their fires burn unseen, steady and patient. They are ancient storytellers, carrying secrets of creation. Whether they mark the first chapter of life or not, they remind us that life finds light even in the darkest night. And that thought is enough to let your breath slow and to let you rest in calm. The oceans are not only vast, they may also be the birthplace of all living things. Around 3.8 billion years ago, the first sparks of life may have risen in the sea. Scientists picture a young planet wrapped in water, with storms flashing above and heat rising below. In 1953, the Miller-Urey experiment showed that simple gases, when struck by lightning, could form amino acids, the building blocks of proteins. This suggested a primordial soup, rich with chemicals, stirred by energy and chance. Other scientists look instead to hydrothermal vents, where mineral-rich water gushes from the crust. There in the darkness, heat and pressure might have driven molecules to combine. Two visions remain in debate. Was it lightning in shallow pools? Or was it fire in the deep that sparked the first cell? Both ideas lead to wonder, because if either is true, then the oceans were indeed the cradle of life. Every tree, every bird, every human heartbeat traces back to those first fragile beginnings. The question still lingers. Did life spark from a bolt of light across the sky? Or from the quiet breath of a vent on the seafloor? The answer is hidden in time beyond memory. Yet the oceans keep the secret with patience. They have held it for billions of years. When you close your eyes tonight, you can imagine that first moment. A single molecule trembling in water. A single bond forming where none existed before. From that small seed, the story of life unfolded. The oceans were the first home, the first shelter, the first mother. They are still with us now, moving around the planet, carrying the memory of beginnings in every tide. Evidence continues to remind us of this ancient possibility. The Miller-Urey experiment was simple yet powerful. By combining gases like methane and ammonia with electric sparks, the scientists created amino acids, the same molecules that make up muscles and skin. It was a glimpse into how chemistry could become biology. In sediments deep beneath the sea floor, researchers have found microbes that are billions of years old. Fossil records from Greenland suggest microbial life formed as early as 3.7 billion years ago. This rapid appearance remains a mystery. How did life emerge so quickly after the Earth cooled? Was the process inevitable once oceans formed, or was it a fragile accident? The oceans seem to have nurtured the first cells as gently as a parent. They provided warmth, shelter, an endless space to multiply. From microbes to algae to fish to mammals, all arose from the blue. The oceans held each stage of growth like a mother carrying her child. Even now, every breath we take carries the echo of that ancient gift. The mystery is not only scientific but emotional. To imagine that all of us share a single watery origin is to feel unity with every living thing. The seas gave us our first heartbeat. They gave us our first step, and they continue to carry us forward. Tonight, when you rest, you may feel this bond. The ocean is not distant. It is within you. It flows in your blood and beats in your chest. It is the oldest memory of life, and it is still singing. The oceans today are not only the birthplace of life, they are the greatest reservoir of diversity. Scientists estimate that about 700,000 species live in the sea, and many more remain undiscovered. The census of marine life, a global effort to catalog ocean creatures, revealed new organisms at every turn. Some were microscopic, others vast and strange. The deep sea remains especially mysterious. In Antarctica, explorers captured images of giant squid drifting in icy waters. These animals had long been the subject of myth, compared to sea monsters told in old stories. Yet here they were, alive and real. Their eyes larger than dinner plates, their bodies stretching longer than a bus. For centuries, sailors told tales of kraken rising from the depths. Science has now shown that truth can be as fantastic as legend. The oceans remind us that myth and reality are closer than we think. Each wave hides a potential story. Each reef holds a secret. To walk along the shore is to stand on the edge of a library still unread. Every shell, every fish, every unseen creature is a page in that book. The oceans are magical because they hold both knowledge and mystery. They are a world where the familiar and the unknown live side by side. When you listen to the sound of waves, you are hearing countless lives moving in rhythm. The oceans are not empty. They are filled with voices. Voices of creatures known and unknown. To imagine them is to dream of a world beyond sight, yet connected to our own. The question of how many species remain hidden continues to guide science. Some believe that the deep sea still shelters thousands of unknown forms. Others warn that pollution and warming may erase them before we even learn their names. The ocean holds both hope and fragility. Examples are clear. The blue whale is the largest animal ever to live, larger even than the biggest dinosaur. Yet it depends on tiny krill for food. Its survival depends on the balance of the sea. At the same time, coral reefs, such as the Great Barrier Reef, are in decline. Rising temperatures bleach them white, leaving behind skeletons of once thriving ecosystems. These reefs are home to countless fish and invertebrates, each one a story now at risk. The contrast is striking. In the same ocean that gives us the giant whale, we also see fragile corals fading away. How many secrets are still waiting beneath the waves? How many species still glow in the dark where no light reaches? How many voices will vanish before they are even heard? The oceans ask these questions with every tide. They invite us to listen. And as you rest tonight, you may imagine those secrets waiting. Imagine the whale drifting in silence. Imagine reefs bursting with color. Imagine unseen creatures swimming in shadows. All are part of the same song. The oceans are a chorus, and each life adds a note. Together they form a lullaby that carries you into calm. The oceans do not rest. Beneath the surface, water is always in motion. These movements are called currents, and they are the bloodstream of the planet. They carry heat, salt, and nutrients across the globe. The Gulf Stream is one of the most famous. It flows from the Gulf of Mexico across the Atlantic toward Europe. This single current warms entire countries, giving them mild winters that would otherwise be frozen. Without it, London might feel as cold as Siberia. In the Pacific, the Kuroshio Current sweeps along the coast of Japan. It is strong and swift, carrying warm water northward, shaping weather and guiding life in the sea. Each current has its own path, its own rhythm, but together they weave a network that regulates climate for all living things. Even ice has its role. In Greenland, massive sheets of ice are melting, and the fresh water flows into the sea. This dilution changes the balance of salt and heat, affecting the way currents move. Scientists watch with care, because small changes in the Arctic can ripple across the entire planet. Currents are gentle to the eye, yet they are powerful beyond measure. They are like the breath of Earth, steady and patient, keeping balance without pause. Imagine them as rivers of warmth in the cold, dark sea. Imagine them as invisible lungs that breathe for the world. Every tide, every storm, every drop of rain is shaped by their movement. As you rest tonight, think of these hidden flows. They are always there, always carrying, always steady. They are Earth's breath, and you are breathing with them. Yet the rhythm of these currents is not guaranteed. Climate change brings new mysteries and new risks. Scientists have found signs that the great conveyor belt of water, known as the Atlantic Meridional Overturning Circulation, may be slowing. In the past, such shifts have led to ice ages. If the system weakens too far, Europe could freeze even as the rest of the world overheats. The idea seems like a paradox. yet it is grounded in history. During the last ice age, currents shifted, and entire climates changed. The question now is whether humanity will witness such change again. Some models predict collapse. Others predict resilience. Debates continue, but the ocean does not reveal its answer easily. We wonder, can these currents flow forever? Or will they falter under the weight of warming seas and melting ice? The ocean whispers but does not speak. For now, the currents still run, still carry, still breathe. But the thought remains. If they stop, the balance of Earth will be undone. As you listen to the quiet tonight, imagine those unseen rivers. They move without pause, yet they are fragile. They hold the story of climate, of past and future. Their song is the heartbeat of the world, and like every heartbeat, it can change. The tides are another pulse of the oceans, one that we can see with our own eyes. They rise and fall with quiet rhythm, guided by the pull of the moon and the distant sun. Isaac Newton described this dance in 1687, showing that gravity stretches the oceans toward the sky. The result is a daily breathing of the sea. Water gathers, water withdraws, and shorelines shift in slow cycles. Yet the tides are more than mechanics. They hold mysteries still unfolding. Marine creatures respond to their rhythm as if the tides were clocks. Fish spawn in tune with the rising waters. Crabs emerge with the low tide to feed. Corals release their eggs when the moon is full. This timing is so precise that it feels like a secret language. Scientists compare it to biological clocks, yet the ocean's clock seems written in the stars. It is a reminder that Earth and Moon are not separate. They are partners in a dance that has lasted for billions of years. The tides are soft steps in that dance. They are the breath of the sea answering the call of the sky. When you listen to the waves tonight, you can hear that rhythm. It is the same rhythm that once guided sailors, that still guides life, that now guides your rest. The tides are a song between Earth and Moon, a song you can hear with your heart. The influence of tides is not only gentle, it is also powerful. In Florida, red tides bloom with toxic algae, coloring the sea and shaping ecosystems. These blooms rise with cycles of tide and temperature. Elsewhere, sea turtles come ashore to nest in patterns linked with lunar tides. The moon calls them, and they answer with generations of life. Some scientists debate how deep this control goes. Do tides truly shape the instincts of marine life? Or are these patterns coincidences woven by chance? The question remains. Yet each example adds to the mystery. The moon pulls on the oceans, and perhaps it pulls on life itself. It whispers through the waves. It whispers through the shells on the shore. It whispers through the creatures that rise and fall with the tide. Tonight, when you close your eyes, you can imagine this whisper, a gentle voice that connects sky and sea, a voice that reaches you as well, steady and calm. The tides are a reminder that nothing stands alone. Earth breathes with the moon, and the moon breathes with Earth. Together they shape the oceans. Together they shape the silence that carries you into sleep, like the gentle pulse of ocean currents and the tender dance of tides with the moon. Cosmic sleep science weaves the universe's lullabies into stories that soothe the soul. Subscribe to let these cosmic rhythms carry you deeper into Earth's enchanting mysteries. The ocean is not silent. Beneath its surface, sound travels farther than it ever could through air. Scientists like Robert Urich showed in 1983 that sound can cross vast distances underwater, carrying with clarity through layers of salt and pressure. Whales know this truth deeply. Blue whales and fin whales sing across thousands of kilometers, their voices reaching others they cannot see. Each call can last for minutes, each song for hours, echoing across entire basins. These sounds are both map and memory, both language and longing. Among them is one mystery that haunts the imagination, the voice of the 52 Hertz whale. Recorded for decades, this call sings at a frequency unlike any other. No whale species matches it, and no other whale has been heard to respond. Some call it the loneliest sound on Earth. It drifts like a cosmic signal, a message without answer, The thought is both sad and beautiful. Perhaps the whale is alone. Perhaps it is simply unique. In either case, the ocean holds its song, and we listen. The sea is a choir, a cathedral of sound, filled with whispers, moans, and echoes. The waves crash, dolphins click, shrimp snap, fish hum, and whales sing. The ocean is alive with voices, each one part of a chorus that never ends. As you imagine these songs tonight, think of them as whispers of nature, reaching gently to your ears. They are not noise. They are lullabies, songs of earth, songs of the deep. But are these songs truly a language? Or are they only signals of biology? Tools for survival without meaning? Scientists debate this question with care. In the 1970s, the first recordings of humpback whale songs revealed long, complex patterns. They shift and evolve over time, like verses in music. Some suggest that males use them to attract mates. Others believe they are social codes, teaching, remembering, even celebrating. The truth remains a mystery. Beyond whales, the ocean offers other voices. Healthy coral reefs create a soundscape of crackles and pops, like a living fire. Tiny creatures move and feed, making a chorus that guides young fish back home. Even reefs sing in their own way. Together, these sounds weave a world we are only beginning to hear. The ocean's songs reach us as data, as recordings, as lines on a graph. Yet they also reach us in another way, as wonder. To hear them is to feel small, yet connected. We may ask, can we ever understand the ocean's songs? Or are they messages not meant for us? Notes in a language we will never speak? Perhaps the answer does not matter. To listen is enough. To rest inside their rhythm is enough. The songs of the ocean carry us, even now, into a quieter sleep. For all the songs above, there is also silence below. The deep ocean, far beneath sunlight, becomes a place of near silence. In the Hadal zones, where pressure crushes and light never reaches, sound is swallowed. NOAA researchers call these areas some of the quietest on Earth. In the Mariana Trench, scientists have discovered zones where almost nothing is heard. The silence there is compared to outer space. It is not simply the absence of sound, but a presence of quiet so profound that it feels alive. Divers who descend into such depths describe it as heavy, almost physical, like being wrapped in a dream without words. The silence is so deep it seems to press against the mind. A reminder that we are guests in a world untouched. To compare it with the night sky feels right. Both are vast, both are mysterious. Both hold secrets beyond our reach. In the silence of the trench, you might imagine galaxies, not fish, stars, not sand. Silence itself becomes the message, a reminder that not all things sing, and not all truths speak. Some are held in stillness, waiting. Yet even in silence there is life. Deep sea creatures adapt to quiet as surely as they adapt to darkness. They do not need songs to find one another. They use light, touch, and patience. Bioluminescent flashes take the place of calls. Slow movements replace hurried signals. For divers who have entered the deep, the silence is not frightening. It is meditative. Many describe it as the closest thing to floating in a dream while awake. In this quiet, they find calm, a peace unlike any above. Scientists wonder if such silence plays a role in evolution. Does it give creatures space to grow slowly, without the noise of surface life? Or is it a barrier, keeping them hidden, keeping us from knowing their world? The debate remains open, as silent as the sea itself. What secrets does this quiet hold? Perhaps answers to the origins of life, perhaps nothing at all. Tonight, as you drift into rest, think of this silence not as emptiness, but as fullness, a quiet that carries you gently, a stillness that holds you safe, a depth that whispers without words. The oceans are silent guardians of the planet. In a world warmed by greenhouse gases, they absorb 90% of the excess heat that would otherwise blaze across the land. This work is hidden beneath waves and currents. It is vast and patient. It is steady like a slow breath that the Earth carries night and day. Scientists at the IPCC and oceanographers around the world measure heat sinking into the depths. They map layers of water that grow warmer year by year. They warn that these stores of warmth change the chemistry and motion of the seas. Look to the Antarctic, where ice shelves melt from unseen warmth below. Warm water eats at the bases of glaciers that once stood like walls of time. This melting alters the balance of fresh and salty water and nudges currents away from the paths they kept for millennia. In the Pacific, warm pools of water expand. Storms draw power from surface heat and rise into typhoons and hurricanes. Coastlines feel the change and communities brace for weather that grows stronger. Coral reefs blanch when temperatures rise by only a few degrees. Organisms adapted to narrow ranges of warmth face waves of stress that leave behind white skeletons where gardens once flourished. The sea offers life and shelter and balance. It also takes on the burden of our emissions quietly and without complaint. Imagine the oceans as hands that hold the planet close. They cradle heat, so the air above remains more moderate, and so life on land can persist in familiar ways. This image can be calming when you sleep and sobering when you think of limits. The seas are both guardian and mirror of our choices. They can carry the heat deep for centuries, and yet their patience is not infinite. They will change, and those changes will return to us through weather and ice and the distribution of life in the sea. As you close your eyes tonight, picture those hands that hold the earth. Feel their steady motion. Listen to the slow pulse of waters that work without pause, and rest in the awareness that these great bodies of blue move for us and with us. But how long can the oceans continue to bear this weight? The question is heavy, and it sits in the work of scientists who monitor the deep and the surface. They watch the slow rise of stored heat, and they model paths that may not be simple to foresee. History offers warnings when we read its record. The Permian extinction more than 200 million years ago shows how oceans changed and life collapsed when environmental balance broke. Back then, the seas warmed and acidified, and oxygen disappeared from large areas. Species vanished, and the course of life on Earth shifted in ways that took millions of years to repair. Today, the mechanisms are different, but the risk remains that a tipping point could push systems into new modes that are harder to return from. Researchers debate scenarios that range from slow adaptation to sudden shifts that reconfigure climate on regional and global scales. In some models, the great conveyor of water weakens and Europe cools even as the tropics warm. In others, currents shift and rainfall patterns change. Deserts can expand and fertile regions can shrink. These paths are not certain yet. They are possible, and they demand care. The seas now hide warmer layers that have rarely felt such heat. Creatures migrate to find cooler waters. Coral gardens dwindle, and fisheries face new patterns that ripple into human life. If the oceans stop absorbing heat as they do now, the air will warm more quickly, and the world will feel that change in storms and harvests and the stability of coasts. For the listener tonight, this picture may sound heavy, yet it also calls for a gentle response. Awareness becomes a form of care, and care leads to choices that can alter the future. Take a breath and imagine the ocean as both shield and book. Reading its pages slowly reveals the past and warns of paths ahead. Knowing this is a quiet way to stand with the sea and to sleep with the thought that we can act to protect the rhythms that sustain us. The oceans not only hold heat, they also breathe with the planet. They absorb about 1/4 of the carbon dioxide that humans release into the air. This work slows the rise of concentrations and makes the atmosphere less harsh than it might otherwise become. Scientists measure how carbon moves into surface waters, how it reacts with marine life, and how some of it sinks into deep layers to be stored for years or centuries. When carbon dissolves in water, it forms acids and changes the balance that many organisms rely upon to build shells and skeletons. Coral polyps struggle as the water chemistry shifts, and reefs that took thousands of years to build face rapid decline. The change is not only about reefs. Organisms across the sea feel the shift. Shells grow thin and larvae fail to survive in waters with altered chemistry. Food webs adjust and some species decline while others may expand. The dance of life in the sea changes shape. In the deep, the ocean can store carbon in sediments and in the bodies of slow-living creatures. This sequestration helps the planet buy time. Yet it is not limitless, and the speed of human emissions tests the capacity of these natural sinks. The oceans breathe for us, drawing down our waste so that we have more time to act. Imagine this image as comfort when storms rage and headlines alarm. The sea is kindly and it works on scales we do not always see. Yet there is cost in this kindness. Acidification dissolves the tools of many animals that depend on calcium to survive. Ecosystems shift, and cultures that rely on the sea feel the change through food and livelihoods. For those lying awake tonight, the thought of the ocean as lungs offers both solace and urgency. The sea breathes slowly and deeply, and we share its breath when we inhale and exhale. The rhythm is mutual, and it asks for gentle stewardship. But patience has its limit, and small signs of strain are rising around the world. In the Pacific, some seashells grow thin and fragile as acidification undermines creatures that build calcium homes. Fishermen notice changes in the catch. Communities that depend on reefs see declines in fish and tourism. The ripple of chemical change reaches human shores. In polar regions, tiny algae bloom under melting ice and act as carbon sponges for a season. They help to draw down some carbon, yet their patterns shift with warming, and their role may not be enough to offset growing emissions. The balance between absorption and harm is delicate, and the more carbon we put into the air, the more the scales tip toward stress. Scientists research whether biological and physical processes can increase uptake, or whether human reduction of emissions is the only reliable path to restore balance. Some propose enhanced methods to capture carbon using sea-based techniques. Others warn of unintended consequences if we intervene without full knowledge. The sea is complex, and its systems interlock in ways that demand caution. If the oceans lose their role as major carbon sinks, the atmosphere will warm faster, and weather patterns will change more abruptly. Agriculture will face shocks, and coastal regions will suffer more storm damage. The social cost of such a shift would be immense. For now, the seas still breathe for us. Each wave brings a slow exchange of gases, and each plankton bloom takes a packet of carbon from the sky. These processes act as a gentle heartbeat that keeps the climate nearer to balance. As you rest tonight, imagine the ocean breathing with you. Each inhale of the sea taking in what we release. Each exhale returning rain and life. The image is tender and it calls for care. To protect this breathing, we must balance our actions and our needs with the patience of the sea. Coral reefs are often described as the rainforests of the sea, and for good reason. According to NOAA, although reefs cover only about 0.1% of the ocean floor, they provide a home for nearly 25% of all marine species. This fact alone shows how disproportionately important they are for the balance of life beneath the waves. Imagine a city so small on the map of the ocean, yet teeming with bustling neighborhoods, each filled with its own residents, stories, and dynamics. That is what coral reefs are to marine life living cities where countless organisms find food, shelter, and safety. The Great Barrier Reef in Australia, stretching over 300 kilometers, is the most famous of these living cities. Visible even from space, within its waters live thousands of species of fish, mollusks, sea turtles, and vibrant corals themselves, forming a self-sustaining community. But coral reefs aren't just natural wonders in the wild. In Japan, artificial reefs made of concrete blocks and sunken ships have been carefully placed to replicate nature's blueprint, attracting fish and reviving ecosystems in areas once barren. These examples reveal how resilient and adaptive reef systems can be, whether built by time or by human hands. Emotionally, they feel like underwater gardens, delicate yet bursting with colors, textures, and motion. Their beauty is alive, changing every moment with the tide. To dive into a coral reef is to step into a living tapestry, woven not by human design but by millions of years of biological artistry. It's humbling to think that such a small fraction of the ocean floor can hold so much life, a hidden metropolis thriving quietly beneath the surface. Beyond their visible beauty, coral reefs hold mysteries that scientists are only beginning to unravel. Recent research suggests that corals may communicate with one another through chemical signals, sending cues about stress, reproduction, or changes in the surrounding environment. In a way, it is reminiscent of how trees in a forest use underground fungal networks to share resources and warnings, a hidden language of survival. The thought of corals speaking to one another challenges the way we see them, not just as passive stones in the sea, but as organisms engaged in subtle, complex interactions. Some scientists wonder whether this behavior could hint at a form of collective intelligence. Others argue it is simply chemistry at work, the result of natural reactions rather than conscious communication. Still, the question lingers. Are we overlooking an intelligence we cannot yet measure? A quiet conversation happening in wavelengths and molecules instead of words and sounds. To imagine corals whispering in currents, signaling across their polyps, is to step into a poetic vision of the ocean itself as a speaking body. Perhaps the sea has always been telling us something through its reefs, and we are only now learning to listen. When framed this way, reefs feel less like inert landscapes and more like dynamic communities. Vibrant, not just in color but in communication, like city streets buzzing with unspoken signals gestures. Glances. Signs reefs may be filled with an invisible language, flowing in the water around them. Are corals speaking to the ocean in ways we don't yet understand? The mystery lingers in the blue silence. Yet for all their resilience, coral reefs are also fragile. They are living flames, flickering with brilliance yet vulnerable to even small changes in their environment. Research dating back to Hogue Goldberg in 1999 revealed that rising ocean temperatures pose a direct threat to coral survival. When the water becomes too warm, corals expel the symbiotic algae that give them both food and their radiant colors. This process, known as bleaching, leaves reefs ghostly white and starved. It is as though the fire within them goes out, leaving only ashes of what once burned bright. Fossil records show that corals have been part of Earth's oceans for over 400 million years, surviving ice ages, continental shifts, and mass extinctions. Yet today, they face one of their greatest challenges in human-driven climate change. In places like the Maldives, restoration projects are underway, where divers carefully plant coral fragments onto frames, nurturing them back into growth. These projects are small sparks of hope, showing that with care and innovation, we can help reefs recover. But the emotional weight remains. To swim among corals is to witness beauty that feels both eternal and fleeting. They glow like underwater flames, stunning, fragile, and always at risk of being extinguished. It reminds us of the delicate balance of life on this planet, where something so old, so enduring, can suddenly become so vulnerable. This fragility raises deep questions about the future of coral reefs. Can they adapt to the warming world, or will they vanish into memory? Some scientists argue that corals have the potential to evolve greater heat tolerance, pointing to reefs that continue to thrive in unusually warm waters, like those in the Persian Gulf. These supercorals survive conditions that would kill others, hinting at a resilience hidden within their biology. The mystery lies in how they manage it. Are they partnering with different algae, shifting their symbiotic balance to survive? Or are they harboring genetic traits we do not yet understand? The comparison has been made to drought-resistant plants that find ways to endure in harsh climates where others cannot. These examples suggest that reefs may hold secrets of adaptation that could inspire not just marine science, but our broader understanding of resilience itself. Yet the debate continues, as the pace of climate change may outstrip corals' ability to adjust. Emotionally, this question strikes at something profound. Resilience is not only about survival, but about transformation. When we look at corals, we are not only seeing fragile beauty, but also ancient teachers of endurance. Can corals teach us about resilience? About finding ways to adapt when the world around us grows unfamiliar and harsh? Or will their silence one day remind us of the cost of inaction? The answer has not yet been written, and the reefs wait quietly beneath the waves, holding their mysteries in blue. Among all the creatures of the ocean, few inspire as much awe and mystery as the octopus. This remarkable animal is unlike almost anything else on Earth. It has 3 hearts that pump blue blood, 8 arms lined with hundreds of sensitive suckers, and the ability to change its color and even its texture in an instant. As Hanlon 2007 demonstrated, octopuses use specialized skin cells called chromatophores to vanish against coral, rock, or sand, transforming into an invisible shadow in the blink of an eye. But beyond their extraordinary biology lies a question that fascinates scientists and dreamers alike: the mystery of their intelligence. Octopuses solve problems, navigate mazes, and sometimes appear to show curiosity about the world around them. Their abilities have been compared to a kind of natural artificial intelligence, an alien mind evolving not on another planet, but within the oceans of Earth. Unlike most creatures, their nervous system is not centralized. 2/3 of their neurons are distributed throughout their arms, giving each limb a degree of independence and agency. This distributed intelligence challenges the very way we think about what it means to have a mind. Emotionally, the octopus feels like an ocean artist, painting itself in new colors with every breath, sculpting its form into coral, stone, or shadow. In their silent transformations, there is something poetic, an echo of wisdom that is ancient, fluid, and profoundly different from our own. They are sages of the sea, carrying secrets we have only begun to uncover. Stories of octopus intelligence are not confined to theory. They have been demonstrated in countless experiments and encounters. In laboratories, octopuses have been observed opening jars to retrieve food, sometimes unscrewing lids with remarkable precision. They have also been seen escaping enclosures, memorizing pathways, and even distinguishing between individual human faces in the wild. Divers tell tales of encounters with giant Pacific octopuses, creatures that can grow to over 4 meters across, wrapping their arms gently around those who approach, curious rather than hostile. These experiences deepen the mystery. Are we witnessing mere instinct, or something closer to consciousness? Scientists debate whether octopuses think in ways that parallel our own, or whether we are projecting human ideas onto alien intelligence. Some suggest that their problem-solving skills and play-like behavior hint at awareness, even personality. Others argue it is all an elaborate set of reflexes honed by evolution, without inner life. Yet the question remains compelling. Are octopuses thinking like us, or are they thinking in a way we cannot yet comprehend? To watch one manipulate an object with careful precision, to see its skin ripple with living color, is to feel as if we are being observed by a mind that is at once familiar and profoundly foreign. In their movements lies a quiet riddle. What does it mean to be intelligent? And how many forms can intelligence take? If octopuses are sages of the ocean's hidden corners, then whales are its storytellers, carrying voices that travel farther than any other sound on Earth. Blue whales, the largest animals to have ever lived, reach lengths of up to 30 meters, their size dwarfing even the largest dinosaurs. Noah. Yet despite their vastness, it is not only their physical presence that astonishes us, but their songs. Whale calls can travel for thousands of kilometers through the ocean's dense medium, low-frequency sound waves carrying across entire basins. The mystery lies in how such communication works, and what it means. Scientists compare it to radio signals, an invisible bridge connecting individuals separated by immense distances. To hear a whale song is to be reminded of something both ancient and otherworldly, a sound that seems to stretch across time as well as space. Emotionally, it feels like listening to a story sung not in words, But in melodies that resonate deep within the body, these songs are not random. They have structure, rhythm, and themes that evolve across years, like epics retold by each generation. Whales remind us that the ocean is not silent, but alive with voices, some of which speak across scales so vast they almost feel cosmic. Their songs transcend the boundaries of species and language, offering stories carried in sound, stories we may never fully understand but that we cannot help but feel. The question of whale songs, what they mean, and why they exist has been a subject of debate for decades. Are these sounds a true language, filled with meaning and intent? Or are they simply biological signals designed to attract mates and coordinate behavior? The debate continues, yet evidence keeps adding new layers to the mystery. Humpback whales, for instance, migrate more than 16,000 kilometers across oceans, and their songs often shift and evolve along the way, like musical themes picked up and altered by distant singers. In 1970, the first commercial recordings of whale songs were released, and the haunting sounds captured the imagination of the world, inspiring environmental movements and reshaping how we see these giants. These recordings revealed a world of structured vocal patterns, phrases, repetitions, crescendos almost like symphonies echoing beneath the waves. To this day, scientists continue to study them, mapping their structures as though decoding an alien script. Yet the question remains unresolved. What stories are whales telling across the oceans? Are they recounting migrations, calling to kin, or simply expressing something we do not yet have the tools to translate? Perhaps, like music in human culture, their songs carry emotion as much as information, grief, joy, longing, or memory. To listen is to feel small, humbled, and connected to something vast. The sea itself becomes a stage, and the whales its singers, telling stories that may outlast us all. Part 3. Geological marvels. Beneath the surface of the oceans lies a vast and hidden mountain system, stretching farther than any chain we see on land. Known as the Mid-Atlantic Ridge, it runs for more than 65,000 kilometers across the seafloor, forming the longest continuous mountain range on Earth. According to NOAA, this immense ridge is created by the slow movement of tectonic plates, where magma rises and cools, forming new crust in a process that has been shaping the planet for millions of years. To imagine its scale is to imagine the Himalayas, but buried beneath waves and currents, unseen yet ever present. These underwater mountains are the backbone of the ocean, a hidden skeleton that supports the seas above. Scientists continue to study their origins, yet the mystery remains profound. Why did the Earth choose to lift such vast ridges in silence, while hiding them away from human eyes? The peaks rise and fall in darkness, a world without sunlight, yet full of energy and force. Some scientists compare their hidden beauty to landscapes of another world, vast ranges that few will ever see. Emotionally, these mountains remind us of endurance. They do not rise in haste. They grow slowly, spreading continents apart, moving nations without anyone noticing. They embody patience, strength, and timelessness. The ocean flows above, storms pass, yet the ridges remain. They carry the memory of Earth's inner fire, breathing quietly beneath the waves. The Mid-Atlantic Ridge is not alone. Across the oceans, volcanic mountains rise and fall, shaping the seafloor in ways that connect past and future. In Hawaii, underwater volcanoes have built islands that reach above the surface, fiery mountains that still grow with each eruption. Along other ridges, ancient fossils lie scattered across the seabed, remnants of creatures that lived millions of years ago, preserved in stone beneath kilometers of water. These geological features are not silent, for they interact with the world above. Some scientists debate whether ridges and volcanoes play a role in regulating climate, releasing minerals and gases that influence ocean chemistry and circulation. Others argue they are purely geological, shaping landscapes without touching the rhythms of life. Yet the debate itself reveals the complexity of the Earth, where rocks and currents are never entirely separate. The question remains, are these underwater mountains shaping the future of Earth in ways we have yet to understand? They are the unseen architects of continents, moving lands apart, creating oceans where none once existed. To reflect on their presence is to feel humbled by the scale of geological time, where change is measured not in centuries, but in millions of years. The ridges remind us that Earth is alive, breathing heat and movement through its crust, whispering its story beneath the weight of the oceans. If the ridges represent the backbone of the oceans, then the Mariana Trench represents their hidden heart, a place of unfathomable depth and silence. At its deepest point, known as Challenger Deep, the trench plunges almost 11 kilometers beneath the surface, a depth so extreme that the pressure is more than 1,000 times greater than at sea level. Jacques Piccard and Don Walsh reached this place in 1960 aboard the bathyscaphe Trieste, a feat that remains legendary in the history of exploration. Yet even today, the trench is largely unknown. The environment is alien, dark, and cold, yet it is not lifeless. Scientists have discovered unique bacteria thriving there, organisms adapted to pressures so immense they would crush steel. These findings inspire comparisons to Martian landscapes, suggesting that life may survive in places far beyond what we once imagined. Emotionally, the trench feels like a doorway to Earth's inner self, a descent into the unknown, a reminder that the planet holds mysteries deeper than any human invention. To contemplate it is to feel the pull of silence, the call of darkness that is not empty but full of secrets. The Mariana Trench stands as a monument to mystery, a place where time itself seems to pause, leaving us with questions that stir both wonder and humility. The history of trench exploration is filled with moments of awe. The 1960 Trieste expedition revealed that life could endure in places once thought impossible. Later missions have discovered amphipods, shrimp-like creatures thriving in high-pressure darkness, and microbial mats that convert chemicals into energy without sunlight. These discoveries show that even the harshest environments may harbor resilience and adaptation. Yet the trench remains debated. Some scientists suggest it could hold species entirely new to science, hidden in caverns and sediments untouched for millions of years. Others believe the extreme conditions make it nearly barren, a void rather than a cradle. The debate continues, and with each deep dive we move closer to answers, but also to new mysteries. The question persists: what secrets does the Mariana Trench hide? Perhaps it is not only a physical place, but also a symbol of how much remains unknown. For as much as we explore, the ocean still conceals vast realms of silence and shadow. To dream of the trench is to dream of the limits of exploration, and to accept that some mysteries may never be fully revealed. It is the ocean's whisper, reminding us that wonder is not only found in what we know, but in what remains unseen. Drift deeper into the vibrant gardens of coral reefs and the silent wisdom of octopuses and whales, where the ocean's mysteries unfold like a dream. Subscribe to Cosmic Sleep Science to explore more enchanting underwater tales that soothe your soul and spark wonder as you sleep. In the far north and south of our planet, the story of the oceans is unfolding in silence. The Arctic ice melts a little more each year, releasing water that raises global sea levels by around 3 millimeters annually, according to the Intergovernmental Panel on Climate Change. At first, this may seem small, yet across decades the effect becomes vast, shifting coastlines, swallowing beaches, and redrawing maps. In places like Tuvalu, tiny islands in the Pacific, the ocean already creeps into villages, flooding wells and homes, leaving people to wonder if their homeland will disappear within their lifetime. In the frozen north, polar bears roam across shrinking platforms of ice, forced to swim longer distances in search of food, their survival tied directly to the rhythm of the melting sea. These examples are not abstract. They are signs, reminders of the deep connection between ice and water, between the poles and the equator. The oceans do not roar their warning. They whisper it through rising tides and shifting waves. They hold the ice gently, and as it melts, they swallow it, quietly telling us that change has already begun. The emotional truth of this story is not anger, but sadness, a slow reminder that even something as vast as the ocean responds to the choices of humankind. To listen to this truth is to feel both humility and responsibility, as if the sea itself is offering us a warning wrapped in silence. Yet the mystery is not only that ice is melting, but that it is melting faster than expected. Models that once predicted centuries of slow change now reveal transitions that echo the sudden shifts of ancient ice ages. During those times, climates turned within decades, reshaping the Earth in ways that forced life to adapt quickly or perish. Scientists debate whether we are witnessing a similar tipping point, one where sea levels rise not gradually but with accelerating force. Can this rise be halted through action, or has it already become inevitable? Some believe new technologies and policies can slow the melt, while others warn that feedback loops, once triggered, cannot be undone. The question lingers like an unanswered echo. Is the ocean sending us a signal about the future? A message written not in words but in waves. The ice that melts is not only water, it is memory, holding within it the history of climates past. Each drop that falls into the sea carries a record of ancient air, trapped for millennia, now released into a warming sky. To see glaciers collapse into the sea is to witness both an end and a beginning, an ancient rhythm repeating itself in a world of human influence. The ocean does not speak loudly, but its signals are clear for those willing to listen. Alongside rising seas, another transformation unfolds within the water itself. The oceans absorb nearly a quarter of the carbon dioxide released into the air, a service that has shielded us from even harsher climates, yet one that comes at a cost. As carbon dissolves into seawater, it forms carbonic acid, lowering the ocean's pH and weakening its ability to sustain life. Corals are among the first to suffer. Once vibrant reefs lose their color, their skeletons dissolve slowly, leaving behind empty frameworks where thriving ecosystems once bloomed. According to NOAA, the rate of acidification today is unprecedented in the geological record, faster even than during the Permian extinction, when oceans lost their balance and vast portions of marine life vanished forever. To compare our present moment to that ancient catastrophe is to realize the scale of risk, yet also the fragility of what we hold. The ocean suffers quietly, without protest, like a friend carrying the weight of our burdens without complaint. It takes in the exa, shielding us from the full force of our own emissions. Yet in doing so, it pays a price. This silent sacrifice reveals the deep connection between humanity and the sea. For what harms one inevitably reaches the other. The ocean does not resist, it absorbs, and in that absorption lies both protection and pain. The signs of acidification appear in many forms. In the Pacific, seashells of tiny creatures known as pteropods weaken and dissolve, their delicate structures unable to withstand the changing chemistry. In the Arctic, blooms of carbon-absorbing algae rise and fall with the seasons, drawing in greenhouse gases, yet also shifting the balance of ecosystems that depend on them. Each example speaks of a world in flux, where the chemistry of water, once stable for millions of years, now bends under the weight of human influence. Scientists debate whether the oceans can heal from this change, or if they are being overwhelmed. Some point to natural buffering systems that may restore balance over centuries, while others warn that ecosystems like coral reefs cannot wait. Their timelines far shorter than geological repair. The question grows sharper with each study. How long can the oceans protect us? And at what cost? To listen closely is to sense both hope and urgency. For the sea has always been resilient, yet even resilience has limits. The waves continue to rise and fall. The tides continue to move. Yet beneath the surface, the balance shifts. The oceans breathe carbon like lungs, but lungs too can falter when burdened beyond their capacity. To reflect on this truth is to realize that the future of the oceans is also the future of ourselves. a shared destiny carried in every tide. For thousands of years, the oceans have shaped the imagination of humanity. They have been mirrors of our hopes and our fears, vast surfaces reflecting both our dreams and our struggles. In every culture, the sea appears as a force both nurturing and dangerous, a reminder of life's endless rhythm. Ancient poets compared the ocean to the heartbeat of the world, always moving, always breathing. From Greece to Japan, the waves became part of myth and art. Greek mythology offered Poseidon, the god of the seas, who wielded his trident to control storms and calm waters. His presence in stories showed how deeply the ocean influenced daily life and spiritual thought. In Japan, artists such as Hokusai captured the sheer energy of the waves. His famous painting of the Great Wave off Kanagawa is more than an image. It is a symbol of both beauty and danger. The wave curls with power, yet it carries a certain serenity. In the Pacific Islands, the ocean became the center of culture. Songs, dances, and oral histories all revolved around the endless horizon. In Nordic sagas, the sea was a passage to other worlds, a highway for gods and mortals alike. Today, when we watch the ocean, we still feel that mixture of awe and respect. We sense that it has always been part of our story, like an endless dream that has never left us. The ocean is not only water, it is memory carried across generations. Its depth holds more than fish or coral. It holds the voices of our ancestors who stood on its shore and wondered just as we do now. One of the mysteries that continues to puzzle scholars and storytellers is why so many cultures share similar myths about the sea. Legends of great floods are found in Mesopotamia, in India, in the Americas, and in Europe. Stories of sunken cities such as Atlantis echo across time. Was there an ancient truth hidden beneath these tales? Perhaps great floods during climate shifts left a deep mark on collective memory. Or perhaps the ocean itself speaks to something universal within us. The dream of crossing beyond the horizon, the fear of what lurks below the waves. Myths are not only imagination, they may be echoes of human experience coded into stories. Some scientists explore the possibility that myths of sea monsters came from encounters with giant squids or whales. Others suggest that the shared themes come from the way the human mind seeks patterns in the unknown. Yet when we listen to these stories, we feel their resonance. They connect us across cultures and centuries. The ocean becomes the stage for a shared human narrative. It tells us that we are not so different no matter where we live. Our ancestors gazed at the same restless waters and drew similar meanings. Is the ocean telling us a story that we have yet to fully understand? Or are we projecting our longing onto its surface? In either case, the mystery remains. A reminder that the ocean is more than nature. It is also the mirror of humanity itself. The modern age has brought new ways of reaching into the depths of the sea. The International Seabed Authority reported in 2020 that deep sea mining is growing as nations seek minerals buried beneath the floor of the ocean. Cobalt, nickel, and rare earth metals lie within nodules scattered across abyssal plains. Resources that are vital for modern technologies such as batteries and renewable energy. Yet the act of mining the ocean floor carries unknown consequences. Ecosystems that took millions of years to form may be disrupted in a matter of days. Fragile corals, bacteria, and fish may disappear before they are even studied. Scientists warn that the damage could be as devastating as deforestation on land, except in an environment far harder to recover. The mystery lies in what we cannot see. The ocean floor is still largely uncharted, less understood than the surface of Mars. When machines begin to strip the sediments, we may disturb connections that maintain the balance of the planet itself. The oceans have always given us food, transportation, and inspiration. But now we must ask, how much more can they give? Every gift comes with responsibility. And the question grows louder. How much do we take before the ocean can no longer recover? Examples already exist of how human exploitation leaves scars in the sea. In Papua New Guinea, experimental mines have disturbed ecosystems with sediment plumes, clouding waters, and suffocating marine life. Across the Pacific, massive fields of plastic float like new continents carried by currents. This debris breaks down into microplastics, entering the food chain from plankton to fish to humans. In both cases, we see how our actions echo back to us. Scientists debate whether sustainable mining is possible or whether it is only an illusion. Can technology be gentle enough to extract without destroying? Or is the very act of extraction a contradiction in itself? Some argue that recycling metals on land could reduce the need to touch the seafloor. Others claim that demand for green energy will inevitably push us deeper into the ocean. The debate remains unsettled, but the urgency is clear. We face a choice between short-term gain and long-term survival. When we take from the ocean, we must ask what we leave behind. The question lingers with each wave. Can we learn to take without harm? Or are we writing a story of loss that future generations will remember as a warning? Far from our planet, another ocean waits beneath the icy surface of Europa, one of Jupiter's moons. NASA scientists confirmed through magnetic field data and imaging that beneath the thick crust of ice lies a vast ocean, perhaps larger than all the oceans of Earth combined. This hidden sea is kept liquid not by sunlight, but by the tidal forces of Jupiter pulling and heating its core. The discovery changes the way we see life in the universe. For if an ocean can exist so far from the sun, then water may not be rare but abundant, a universal element waiting to be found. The mystery grows deeper when we compare Europa's hidden ocean with hydrothermal vents on Earth's ocean floor. In our own seas, life thrives around vents without sunlight, feeding on minerals and heat alone. Tube worms, crabs, and microorganisms create entire ecosystems in complete darkness. Could the same be happening in Europa? Could there be microbes swimming near its vents, transforming chemicals into energy? If so, then life may not be limited to warm, sunlit worlds, but could be a cosmic rule. The emotional weight of this thought is immense. Oceans, then, are not just Earth's cradle, they may be the universe's song, repeating itself on distant moons and planets, reminding us that water is not only substance, but also story, a thread that ties us to possibilities beyond imagination. When we look at Europa shimmering in the telescope's eye, we are not just seeing ice. We are seeing a mirror of our own oceans whispering across space, inviting us to listen. Scientists debate what Europa's ocean truly holds. Some argue that beneath the ice microbes could live in ways similar to those at Earth's vents, while others suggest the ocean may be sterile frozen water with no chemistry for life. Data from the Galileo mission provided clues. Plumes of water vapor erupted from cracks in Europa's surface, hinting that the ocean communicates with the sky above. Later observations confirmed these plumes releasing salts and organic molecules, a sign that the ocean may indeed be active. Enceladus, another moon of Saturn, adds to the story. Its south pole sprays fountains of water ice into space, creating one of Saturn's rings. Within those plumes, Cassini detected simple organic compounds and the chemistry for life. Together, these worlds tell us that oceans may not be rare accidents, but recurring features of the cosmos. Every discovery reshapes the question of whether life is alone. The ocean becomes a symbol not only of water, but of possibility. Waiting beneath surfaces both near and far are cosmic oceans waiting for us to explore. Are they waiting to teach us that life is not the exception, but the expectation? And if so, then every wave on Earth may carry an echo of waves rolling in distant seas. The oceans of Earth hold a mystery not only in their depth, but in their origin. Scientists once thought water came from inside the Earth itself, released by volcanic gases. But new studies reveal another possibility. Our oceans may have arrived from space. Comets and asteroids carrying ice and dust may have delivered water in the early days of the solar system. Hartog in 2011 showed that the isotopes of hydrogen in some comets matched those in Earth's oceans, suggesting that part of our seas may be cosmic in birth. This finding reshapes how we think about water. It may be the common thread connecting planets, moons, and stars. Not just a feature of Earth, but a substance written into the language of the cosmos. Mars shows evidence of once flowing rivers now dry. Comets trail ice as they pass near the sun, and distant exoplanets appear to hold oceans of vapor or ice. The comparison draws us into a wider vision. Our oceans are not isolated. They are kin to waters elsewhere, and this connection carries emotion. It suggests that every drop of water we touch may have once traveled across space as dust or ice before falling here. Oceans, then, are bridges, not boundaries. They connect us to the universe, reminding us that we are not separate, but part of a larger story. The oceans become our inheritance from the stars, a gift of cosmic origin that still flows on our shores. Missions such as Rosetta in 2014 deepened this vision when the spacecraft followed Comet 67P and measured its water, comparing it with Earth's seas. While the exact match was debated, the discovery kept the question alive. Later lunar missions detected water molecules locked in craters on the moon, showing that water exists even where sunlight never reaches. Step by step, the evidence grows. Water is everywhere, not only here. And the oceans of Earth remind us that we live within a universe where water connects worlds. Returning to the present, we must ask what legacy we leave with this knowledge. If oceans link us to the stars, do we honor them or exploit them? Do we see them as sacred gifts or as resources to spend? The ocean is both shield and teacher. It protects us from heat. It provides food. It inspires myths. Yet it is fragile. Every drop of ocean water tells a cosmic story, one of creation, survival, and connection. The question now rests with us. Will future generations inherit oceans still alive with beauty? Or will they inherit only memories of waves that once carried the song of the universe?